Hello, everyone, and welcome to Techie. Let's start with a really big question. How is it possible that billions of completely different devices can all speak the same universal language? I mean, how does your phone, your laptop, and some random server on the other side of the planet all manage to communicate flawlessly?
Well, the secret sauce really is something called a network model, and you can think of it just like a universal rulebook for communication. It's a shared set of guidelines that makes sure every single device out there, no matter who made it or what software it's running, is playing by the exact same rules when it sends and receives data. So today, we're going to dive into the two most important models in the world of networking. And we're going to start with the big one, the comprehensive blueprint of them all, the OSI model.
Okay, so the OSI model, that stands for Open Systems Interconnection. Back in the 80s, the International Organization for Standardization, that's the ISO, embarked on this huge project to create a single, universal guide for all networking. The key thing to get here is that it explains what needs to happen for two devices to talk, but it doesn't get into the nitty-gritty of how. So it's not really an instruction manual, it's more like a grand architectural blueprint. And the way it does this is actually pretty brilliant. It takes this incredibly complex process, like sending a simple email, and breaks it down into 7 separate, manageable layers. As you can see, each one of these layers has a very specific job to do, kind of like an assembly line. So when you send some data, it actually travels down the stack. It all starts at the very top, at the application layer. That's where your browser or email client lives. From there, it moves down, getting formatted, having a session managed, and making sure the transport is reliable. Then the lower layers kick in to handle all the logistics. You've got the network layer finding the best route, the data link layer getting it ready for the local network, and boom, the physical layer turns it all into raw bits, actual electrical signals or radio waves. Now, this is super important. There's this process called encapsulation. As your data goes down through each of those layers we just talked about, each layer adds its own little piece of info, called a header. The analogy here is perfect. It's exactly like putting a letter in an envelope, then putting that envelope inside a slightly bigger one, and then another one, and so on. By the time it hits the wire, your original data is all wrapped up in these different layers of instructions. All right, so that's the beautiful theoretical blueprint. But now, let's talk about reality. Let's talk about the model that is actually running the internet right now, the TCP/IP model. You see, the TCP/IP model has a totally different origin story. It wasn't dreamed up in some standards committee. Nope. It was built by the US Department of Defense for a very real project called ARPANET, which you might know as the forerunner to the internet. Their whole goal was to build a network that was tough, one that could survive just about anything. And because it was built for the real world, it's no surprise it became the standard. And right away, you'll notice a huge difference. Compared to the 7 layers of OSI, TCP/IP is way more streamlined. It just bundles everything into 4 consolidated layers. It's all about efficiency and just getting the job done. And each of these 4 layers is a real workhorse. The application layer up top, it just combines the top 3 OSI layers into one to handle all those protocols you've heard of, like HTTP. Then you've got the transport layer, which is all about how the data gets there. It has 2 star players, TCP, which is super reliable, and UDP, which is all about speed. The internet layer is where the famous Internet Protocol, or IP, lives. Its job is addressing and routing. And finally, the network access layer handles all the physical stuff, getting the data onto the actual hardware. This mapping really makes it all click, doesn't it? You can see exactly how TCP/IP's application layer just gobbles up the top 3 layers of OSI, and down at the bottom, its network access layer combines the 2 lowest OSI layers. It's just a much more practical, down-to-earth structure. Okay, so we've met the players, we understand the OSI model and the TCP/IP model. Now let's put them head-to-head. Let's really dig into the core differences, because that's where things get interesting. The timeline here tells a really important story. TCP/IP was built back in the 70s for an actual working network. So by the time the more, let's say, academic OSI model showed up in the 80s, TCP/IP was already out there, being used and getting popular. It had a massive head start in the real world, and that's a huge deal. And this table just lays it all out perfectly. The OSI model is prescriptive. It's like a rulebook saying how things should be done, and it's not tied to any specific technology. TCP/IP, on the other hand, is descriptive. It's basically a manual for how the internet actually works,
built specifically around its key protocols TCP and IP.
So this always leads to the big question, which one is better? And honestly, that's totally the wrong way to think about it. This isn't a competition. The reality is, for anyone working in networking today, they're both absolutely essential tools in your toolkit.
At the end of the day, they just do different jobs. The OSI model, that's your best friend when you're learning the fundamentals or when something breaks and you need to troubleshoot it systematically, going layer by layer to find the problem. But the TCP IP model, that's what you use to actually design, build, and run a network, because it's a direct map to the technologies we all use every single day.
Here's another way to think about it that I really like. The OSI model is like a super detailed city map, showing every single tiny street and alleyway. It's perfect for when you need to pinpoint the exact source of a problem. TCP/IP, though, is the highway system. It's the major roads that all the traffic actually flows on. You absolutely need both to get around effectively. And really, that's the bottom line. Knowing both of these models inside and out is what takes a network pro from just good to great. It means you can build strong, efficient networks, and just as importantly, when things go wrong, and they always do, you have a logical roadmap to find and fix the problem fast.
Hey, if you found this explainer helpful, do us a huge favor and hit that like button and subscribe to Techie. It really does help us out and lets us know that you want more clear, no-nonsense tech breakdowns just like this one. But before we wrap up, I want to leave you with a question to chew on. These two models have been the absolute foundation of networking for decades. But now, think about all the crazy stuff happening. 5G, the Internet of Things, massive cloud computing. These are totally changing the game. So, do you think these models are going to last forever? Or are we on the verge of needing a brand new model for the future? Drop your thoughts in the comments. I genuinely love to know what you think. Thanks for watching.